All right, we're talking about section 2.4, relations and functions. We're going to start things off by talking about what is a relation. Let's go to work. What is a relation? Wow, look at all those blank stares. Okay. Relation could be called a coordinate. It could be called a point. It could be called a ordered pair. In math, a relation is between an x value and a y value. It's another name for an x value.
Zero. Zeros.
X-intercepts would be called zeros. Okay, I like what you said. Domain. What's another name for x value? Input or independent variable. Okay, so what are names for the y values? Range, output, or the dependent. Now, I know you can't see the, well, I guess maybe I can. Yeah, you can't see this at home for those of you who are listening online, but if you put your hands out in front of you, literally put your hands out in front of you with your palms together. We're going to separate our hands horizontally and say X. Bring the hands back together. Then we're going to separate them vertically and say Y. X, Y. Input, output, domain, range, independent, dependent. So we're going opposite direction, horizontally and then vertically each time. One more time. Do it with me, please. X, Y. Input, output, domain, range, independent, dependent. A lot of times those terms are interchangeable, okay? And I think it's important that you know all of those because I'm going to ask you what the domain is, and you guys are probably a lot better at that now than you were when you were a freshman. But domain, man, somebody asked, hey, what's the domain? And everybody goes, what? Because you could ask the exact same question and say, hey, what's the x values? Oh, it's 2, 3, 4. You know what I'm saying? Okay, so a relation is just an ordered pair. Anytime that we can come up with an input and an output, that's a relation. Anytime that we can come up with an input and an output, we have a relation. Now, relations are pretty simple. It's kind of, never mind, I ain't going there. Relations are simple. Okay, you just have to have an input and output, an x and a y, some kind of connection. However, a function, now that's important. Can anybody give me the definition of a function? Very good. Each input has exactly one output. Now that is a very, very easy definition. A function. Each input has one output. Okay? But depending on how you look at it, it can become very difficult to determine. Not very difficult, but causes people problems. Let's look at a lazy table. X and Y. 2, 3, 4, 5, 6, 8, 9, 10, 7, 2. Is this a function? Is this table of data I just gave you a function? Yes, it is. Why? Because each input has exactly one output. Here's where I always struggled with this. You know, you've done T-charts forever. You get some equation and you do a T-chart. And that T-chart doesn't include all the values, does it? So as I first started looking at these things, I was thinking, oh, okay, I don't see any repeated inputs here, but what's telling me that there's not another one outside of those inputs that I chose, right? Anybody else struggle with that as you start talking about functions? When you're talking about a table, though, even though it could be representative of an equation, when you have a table, you have to think, that's it. That's all the inputs, that's all the outputs. There are no more. Okay? So if you can now take your brain and just look at that and say, I have 5 inputs and I have 5 outputs. And each input has exactly one output. I'm good. It's a function. Right? Okay, so if anytime we're looking at a table, what's going to be the first thing we're looking for to decide if we're going to have a function or not? The first thing we're going to look for is a repeated input. Let's say I have another 2 up here. Now I have a repeated input. Because I have repeated inputs, is this all of a sudden no longer a function? There's, for you at home, you didn't get to see all the heads in the room. Nod, yes. Well, I have a repeated input, so it's no longer a function. What if it's an 8? What if the output right there is an 8? Boy, that's still a function then, isn't it? Yes, it would still be a function because even though it appears twice, the input is 2, the output is 8. Same input, one output. Are you with me? Now, I will give you the fact that most of the time, see, if I put in anything other than 8 in that spot, it's not going to be a function. You know? And we can see that really quickly. But I don't want you to, at this point in your career, you should know just because there's a repeated input doesn't mean it's not a function. It's probably not. I mean, it's a 99.9% chance it's not going to be a function, right? But I have to look at the output because the function is the relation between the input and the output. Here's the other thing that people struggle with when it comes to tables. Is this a function? Yes. Anybody say no? But wait a minute, 5's with all of them. Doesn't matter. Each input has one output. Now, I've got a favorite way I like to talk about this normally, but I'm not going to go there today either.
Y gets to cheat and X doesn't get
Yeah,
to cheat.
Y can cheat, X can't. I mean, that's, and if we think of biology, you know, X is the female and Y is the male. But guys, don't ever do that. That would be bad. That would be bad. Okay. So, if we look at it just a table, you just got to look for repeated inputs. Look for repeated inputs. Then compare those outputs. Okay? How else can we have a relation that we're trying to test whether it's a function or not? Well, we can have an equation. Is y equals x plus 2 a function? Yes, it is. How do you know? Matt, how do you know that that's a function?
Because it just has one output and input.
Okay. Okay. Can anybody give me an example of an equation that's not a function? Yes, sir. X equals y plus 5 is a function. But I like what you're thinking. Cole?
XY equals 2.
X, y equals 2. Nope, that's a function.
Why?
Why is it a function?
Yeah.
Okay. I'm going to, I'm, one way I could do it is I could graph it. X, y equals 2. I could graph it. I could look at my graph and see if my graph passes the vertical line test, which it will. Right? Yes, sir?
X equals y squared plus 5.
X equals y squared plus 5. No longer a function. Now, x is still to the first degree. All has to be the first degree? How about this one? Y equals x squared.
The Y has to be the first degree.
Y has to be to the first degree. Thank you. Y has to be to the first degree. Okay. For bonus, and I'm going to give you this. Everybody should be able to recognize this function. X squared plus y squared equals r squared. In this case, I could change that r squared to be, 9 or 4 or whatever. You recognize that function?
Yeah, we just did.
Well, actually, it's not a function. You recognize that equation.
We just did this.
What is it? What equation is that? It's the circle. Okay? It's a circle. Right? And a circle is not a function. Correct? I mean, it's a relation, but it's not a function because it doesn't pass the vertical line test because each input has more than one output. Okay? Therefore, it's not a function. But we can also see that this is squared, which is what we just came up with. Let me ask you this, though. What about this one? X plus y cubed equals 9. Would that be a function? Because we just said it had to be to the first power. Does it have to be the first power? Well, I don't know here, do I? So what can I do to test?
Cube each side.
How about we graph it? I'm going to, for fun, let's go to Desmos. Let's use our technology. Let's use our powers of deduction. What was it? X plus y. This has got to move. Cubed equals 9. Is that a function?
Yeah.
Is it only odd? Oh, degrees.
There we go. Odd degrees. Y has to be to an odd degree. Or does this thing get vertical right here? Is this thing not a function because it's vertical at this one? I mean, look, I keep zooming in. Is that thing vertical at all? Sure getting close, but is it vertical?
No.
No. So to be advanced power, okay. So in order for us to have a function in equation form, your y cannot be to an even power. Okay, it can't be to an even power. Now, are you going to come across that? I don't know. Probably not. The most common thing you're going to see is that your y is to the first power. Okay. Next, the easiest way to determine whether something is a function or not is to look at its graph, as we just did. And with today's technology, we can see the graphs easily. And when we look at the graph, we're going to apply the vertical line test. Now, you should be able to look at most equations and see that the y is not to a power other than 1, and you should be fine. Okay? But we can get to some pretty hairy stuff. All right. Otherwise, there could be situational things that could be functions, and you just gotta think about it reasonably. For example, I'm going to give you a situation, and you tell me whether it's a function or not. Okay? A person's age is the input. Person's age is the input. And their output is how much money they make. Is that a function or not? I got some heads shaking yes, and I got some heads shaking no. No, it can't depend. It's either a function or it's not. Each input has only one output, or it's got more than one output.
Someone's age.
Person's age
And how much money they make.
and how much money they make in a year.
No.
Function or no?
No.
How many people say yes? How many people say no? Everybody's against you. Why is it a function?
Well, you got me there.
All right. When you're trying to prove that it's a function, look at an input. Okay? So let's say 16. So a person's age 16. And how old are you?
I'm 17.
Okay, 17. So 17. We'll use 17. How much money did you make this past year?
Not much.
Give me the number. Huh?
Like $1,000.
$1,000. So every 17-year-old has to make exactly $1,000. Is that true or false?
False.
Then it's not a function. Are you with me? And that's what you have to do in a situational. And if you can come up with one example that's not true, what's that called? What's it called if the name of something that you can give that disproves something? Do you know what that's called?
No.
It's called a counterexample. You want to write that down. It's called a counterexample, all one word, counterexample. Counterexample is an example that disproves something or shows that it's false. All right, we're going to give you another one. Input is a person's age. Output is the number of birthdays they've had. Person's age, the number of birthdays they've had. Function or not a function?
Yes.
Yes, because every 5-year-old has had 5 birthdays.
I'm 17. Okay,
Are you a
I was thinking. No, I was thinking birthday parties. Birthday.
Gotcha.
Parties.
Gotcha. I was going to wonder if you were a leap year baby.
No.
Oh, wait, then it's not a function. Because what about the people that are born?
Because people who are born on leap year technically don't have a leap year birthday. They either get February 28th or March 1st as their birthday. Anybody in here from China?
No.
No?
Why
Do you know
are
that?
raising your hand?
Do you know?
You're not from China.
Do you know that Chinese do their birthdays differently?
Yes. How so?
You could be born on December 31st. Okay, and the very next day, you would be 2 years old.
Oh, because you lived in 2 different years.
So Chinese age is done by how many years you have been alive and how many calendar years you have been alive, not your age like we think of it.
Is that why the oldest people in the Guinness World Record books are always Chinese?
I have no idea. I don't know. I had 2 Chinese students when I was in Abbeville, and they both said they were 18, but according to their age, they were 18, but according to our age, we were like 16 because they count years of life versus. So anyhow, it's just something different. Can anybody come up with a real world example of a function for me?
No.
Yes, you can. Come on. I'll give you one more, and then I'm going to challenge you guys. Got to come up with at least one. A person's identity just means each individual person. Okay, person's identity as input, social security number is output. Function or not?
Yes,
Why is that a function, Cole?
because everyone's social security number is different.
That's right. No two people have the same social security number. Not legally, anyhow. Come on, come up with one function for me.
Oh. Everybody's fingers and their thumbprints.
But if you don't have some,
A person's hand is the input, and the output is their fingerprint. Function or not? Yes, function. Good. So you get. All right. So we understand what a function is. Okay, something that goes along with functions is evaluations. Or evaluate. What does it mean to evaluate a function? Well, that means glade. See, when I lived in the South, there were all these commercials, for Glade plugins. You know what a Glade plug-in is, right? It makes your room smell good.
Yeah.
There would be all these commercials, and it'd be some mama walking into her son's bedroom. Oh, good Lord, it stinks in here so bad. Be a nice place for one of their plug-ins right there,
that's usually it.
And so I always like to say, all you have to do is, just like a Glade plug-in, all you got to do is plug it in. Anyhow, those commercials in the South always had Southern actors, and they just had a little bit of twang to what they were saying. Oh, good Lord, it stinks in here. This is where we need to put one of them there vanilla plug-ins right there. Mm-hmm.
I don't think vanilla will combat doggy things. Sorry.
Plug it in. Plug it in. Plug it in. Plug it in. As a reminder, I'm sure you guys are fine with this. F of X is just function notation for Y. You guys are okay with that at this point, right?
Yeah.
You can totally interchange an F of X and a Y. See, at some point, you struggled with this. Back in the day, you used to get like X plus 3, and your teacher would say, I hate it when that happens. And your teacher would say, what if X equals 4?
What are you?
I know.
This looks like something I should. I know.
You would have something like this, X plus 3, and your teacher would say, hey, if X equals 4, what would you do? You'd plug it in and you'd say 4 plus 3 equals 7, right? Originally, that's how you started learning to plug things in. But now we want to use function notation and say, hey, f of x, some function equals x plus 3. What if you substitute in 4? What happens? It's the same process. It's just now using function notation to do that same thing. Yes? So that's what evaluating a function is. Just plugging in the value in for the variable. Go ahead.
When we go over in this section, so you would have to do f of x and g of x, and then f of x is inside of g of x.
Yes, those are Those are called function composition or composite functions. I'll help you with that. That is not this section 2.4, but it is in this unit. I think it's the next section, actually. We'll be doing inverse functions and composition or composite. Keep saying composition, composite functions. All right, so I'm going to stop there since the thing broke down anyhow. That should give us a good start. Okay.